कर दूं मैम स्टार्ट?
Hello everyone, I am here to discuss the HDFS commands in big data. HDFS is the file system of Hadoop. HDFS stand for Hadoop Distributed File System. In the last lecture we have discussed the HDFS architecture, file input, output, read, write operations. Now we will discuss what are the HDFS commands. To use the HDFS command, first you need to start the Hadoop services using the following command: bin star all.sh. All the Hadoop activities, Hadoop server, Hadoop services will be started by using this command. To check the Hadoop services are up and running, use the following command: jps. So if we write jps on the terminal, then it will show the how many daemons are activated: secondary name node, data node. These are the HDFS daemons. Resource manager, node manager. Then ls command, sorry. This command is used to list all the files. Use LSR for recursive approach. It is useful when we want a hierarchy of a folder. If we use ls, then it will show the list of files, and if we use LSR, then it will show the list of files recursively. Means from the file on which it is from subdirectory till the directory in which file resides. mkdir command to create a directory in Hadoop DFS. There is no home directory by default, so we have to create it. This is the command bin HDFS. This is common in all in the bin folder. HDFS DFS is for distributed file system. Then hyphen. This will be the same in all the HDFS command. This till DFS. Then if you have to only you have to change the command name. Then hyphen, it is common in all the commands. mkdir, then folder name. Creating home directory, HDFS bin mkdir user directory you have created. Then z, it creates an empty file. The command of z is there. Copy from local or put. It is an important command in HDFS to copy file folder from the local file system to the HDFS store. This is the syntax of this: bin HDFS DFS hyphen copy from local, or you can write put only. Put the local file path and destination path, the source path to destination path. Then cat is used for printing the file contents. So this is the syntax for this. If, for example, if you want to print the content of ai.txt file, then in the geeks folder, then you this is the command you have to run: bin HDFS DFS hyphen cat. Cat is the command, the geeks is the folder, and ai.txt. Then this is the output. The content of ai.txt is shown here. Copy from local, we have studied. Next is copy to local, means get command. It means you are to copy file from folder from HDFS store to the local file system. This is the syntax: bin HDFS DFS copy to local, or you can write get instead of this. The source path and destination path, because you are copying file from the HDFS to the local file system. Move from local, it is just moving the, not copying, the moving the file from local to the HDFS. This is the command syntax for this. Then cp is, this command is used to copy files within HDFS, means from one HDFS folder to the another HDFS folder. So you can write the same syntax, bin HDFS DFS hyphen CT, then source is geeks, and you are copying file from geeks to them, the destination will be geeks. RMR, this command is very important. It deletes a file from HDFS recursively. It is very useful command when you want to delete a non-empty directory. So this, for example, this command RMR geeks copied, it will delete all the content inside the directory, then the directory itself. RMR for recursively deleting. DUS, this command will give the total size of the directory or file, and DU it will give the size of each file in the directory. Set REP. This command is used to change the replication factor of a file or directory in HDFS. By default it is 3 for anything which is stored in HDFS, but as it is set on the HDFS core site.html, XML. So in the example, we are changing the replication factor to 6 from geeks.txt stored in HDFS. So this hyphen set rep hyphen r, capital R, then small hyphen small w 6. 6 is the replication you want to change from default 3 to 6, and this is the file for which you are changing the replication vector. W means wait till the replication is completed, and R means recursively. We use it for directory as they may also contain many other files and folders inside them. So the next topic is data ingestion with Flume and Scoop. These two are the data. We have, in the first, the layers of big data architecture, the data ingestion layer is, first is data source layer, second is data ingestion layer. So in data ingestion layer, the application and tools are used for ingesting data from the structured data sources, semi-structured data sources and unstructured data sources. So these two applications are used for data ingestion in Hadoop architecture. Data ingestion is critical and should be emphasized for any big data project, and the volume of data is usually in terabytes or petabytes, maybe exabytes. Petabytes we have already discussed. These are the, it is 10 raised to power 15 bytes of data. So big data is dealing with the petabytes of data. Handling use of data is always challenging and critical. So rather than writing an application to move data into HDFS, we can use some existing tools for ingesting data because they cover many of the common requirements. For example, Flume and Scoop. So what is Apache Flume? Apache Flume is a system for moving large quantities of streaming data in HDFS. So basically, Apache Flume is for ingesting real-time streaming data like log files, event files, and Scoop is for ingesting structured data. So first we will discuss in detail Apache Flume. It is a system for moving large quantity of streaming data into HDFS. A very common use case, collecting log data from one system like a bank web servers and aggregating it in HDFS for later analysis. This is the diagram which is showing that data is, we are collecting data from the cloud, Facebook, Twitter, web servers. These are the log and event data generators. Actually Flume ingests that log and event data. These are the streaming and live data. And Flume, this is the tool that we are using, and log and event data is saved in the HBase or HDFS. These are the centralized store for the big data storage. More about Apache Flume. Apache Flume is a tool service data ingestion mechanism for collecting, aggregating and transporting large amount of streaming data such as log files, event from various sources to a centralized data store. Flume is a highly reliable, distributed and configurable tool. It is principally designed to copy streaming or log data from web servers to the HDFS. Then comes Apache Scoop. Scoop is, as already discussed, it is for ingesting structured data into the HDFS. HDFS store or HBase store or the Hadoop file system storage systems. Scoop is a tool designed to transfer data between Hadoop and relational database servers. It is used to import data from relational database such as MySQL, Oracle to HDFS and export from HDFS to relational database. This is the diagram for RDBMS sources, MySQL, Oracle, DB2, Scoop tool, importing and exporting the both way communication, both way ingesting and transfer of data exists here in the HDFS and Hadoop. So here comes the line by line difference between Scoop and Flume. Scoop is for structured data, it is for streaming data. Scoop has a connector based architecture. Connector know how to connect to respective data and fetch the data. Flume has an agent based architecture, that is code is written which take care of the fetching data. Scoop data is not event driven, while Flume data can be driven by an event. In order to import from structured data, one has to use scoop commands only because it interact with the structured data sources and fetch from them. While in order to load streaming data such as tweets from Twitter or log files or web server, Flume should be used. Flume agents are built for fetching streaming data.